So I think a global electric circuit is an electric circuit that goes around the Earth.
It's in the atmosphere. It's not like in space. It's for like electric things like cell phones or power plants or radios or computers or games.
I'm pretty sure it's natural because it's out in nature.
When we talk about the global electric circuit, we are describing how electricity naturally flows throughout Earth's atmosphere. It can be generated by the interaction of solar wind with Earth's magnetic field, down to the electricity that individual clouds produce. Clouds that produce lightning in a thunderstorm, for instance, feed electricity into the global circuit also. They're all a part of the same system. While we have known for a while that electricity exists in the atmosphere, scientists are just beginning to understand the relationships between the different events that affect it. Could the amount of electricity in the atmosphere change the way clouds and storms develop? Could cosmic rays impact atmospheric electricity and the severity of winter storms? By doing basic research and creating computer models, scientists hope to answer these kinds of questions, and perhaps find answers to questions we haven't even thought to ask yet.
Some kind of light show that moves throughout an area is what my guess would be.
First of all, it sounds like pop and sprites.
I guess they're like people who travel around Earth trying to find where places where lightning hits and if it makes a fire.
Fairies who live in a forest.
I believe elves and sprites are little people. Magical, mystical creatures.
They're not Santa's elves.
What if I told you that scientists have taken pictures of what look like 20-mile-tall giant jellyfish in the upper atmosphere that appear for a few milliseconds and then vanish? Or that scientists have found visible electric donuts that are 190 miles in diameter? Together, these are called Transient Luminous Events, or TLEs, most of which appear in the sky above large storms during lightning strikes. Sprites can look like columns, carrots, or jellyfish and appear in an area of our atmosphere called the mesosphere. Elves are huge expanding rings of electricity that can reach up into even higher layers of our atmosphere and the highly electrified ionosphere. And that's not all. Blue jets shoot out of electrified clouds with or without lightning. Scientists are trying to find out how these TLEs interact with the global electric circuit and what impact they have. Most of all, they want to know how to represent these interactions mathematically in a model of the system, and that's not easy.
Like different computer models have different things in them, like maybe one has a different processor than the other, which would have a different model. One may look different.
In kindergarten, I made a model of the Earth with a balloon.
Models are simply representations of real-life phenomena. While most of us are familiar with these kinds of models, did you know that mathematical equations could be used as models as well? We use math to represent natural phenomena, like how much energy Earth receives from the sun, and the weather that emerges as a result. By taking these things we know and translating them into a mathematical model, we can build a pretend Earth, a model to test things that we never could in the real world. Because models have to calculate so much math and can end up having so many variables, we use supercomputers. They help us predict what is likely to occur, from tornado-producing storms on the Great Plains to hurricanes forming in the Atlantic. Trying to create a model for the global electric circuit presents incredible challenges. First of all, studying the global electric circuit requires experts across many areas. Scientists who specialize in the uppermost atmosphere, solar wind, electromagnetism, chemistry, the physics of lightning, cloud formation, volcanic weather, and more. Secondly, the model is trying to encompass events that are a part of the global electric circuit on vastly different time and spatial scales. from sprites that appear for a few milliseconds to the 11-year solar cycle, or enormous events like gamma-ray bursts down to small particles that influence cloud formation and cloud electrification. And there's even uncertainties about how clouds are charged and how atmospheric conductivity occurs and breaks down. Scientists and mathematicians are trying to create a model that is flexible enough to handle all of those variables. It's a challenge, but there is no time like the present to seek answers to scientific frontiers. So what is the global electric circuit? It's a system that encompasses all of the electrical generators, currents, and TLEs in Earth's atmosphere. Because of observations, satellites, ground-based networks, and observations of electrical phenomena between clouds and the ionosphere, we know a lot more about Earth's global electric circuit that transverses Earth's upper and lower atmosphere, but we still have a lot to discover about the system. Basic research will help us get the answers we seek. Basic research is essentially asking questions about the natural world that, when answered, will result in new knowledge. It's the heart of all science, and the things we learn from this basic research then lead to even more discoveries. It all begins with basic research. Dr. Jeffrey Forbes is leading the team attempting to model the global electric circuit, and he sums it up pretty well.
We think that by pursuing an improved knowledge of the whole global electric system, that discoveries will emerge that we might not have even have anticipated. And that's the way basic research goes. It wouldn't be called basic research if we already knew what the outcome was going to be.